Greetings and welcome to C++ 3D game engine tutorial series. In this video, we will create a simple window in C++ using DirectX12 and WindowAPI. Let's get started. First of all, let's create our project. I'm using Visual Studio 2022. Let's select the empty project in C++. Choose C++ and select empty project, then click Next. Here you can choose the location of the project and set the project name. I'm using cosmoengine as my project name, so let's create the project. Here you have filters or so-called folders. Then you have to set up the properties of our project. Let's go to Properties. To prevent further errors, let's edit active platforms. So remove x86 platform, and in platform also remove Win32 platform. So make sure that you have only x64 platform in release configuration and debug configuration. Let's change the output directory. I prefer to change the output directory so you can locate all your build files in bin directory. And for intermediate directory, I prefer to use object directory as my parent folder for all intermediate build files. So you can manually change it later. Let's also select the latest C++ language standard. And that's it. You have completely set up your project. And by the way, let's create our first file. Our first file will be main.cpp. It's source file, and this is entry point of our program. Last but not least, change the preprocessor settings. Let's go to C++, preprocessor, and edit preprocessor definitions. We can manually add Win32. So let's write in this window Win32 and try to find some macros. So we can manually paste it here. Click Apply, and that's it. So let's change some conformance mode to be the default in language. For speeding up the build time, we can use precompiled header in precompiled headers. Go to linker input and add additional dependencies. We will use d3d12.lib, dxgi.lib, and d3d compiler.lib. Also, we have manually delay loaded DLLs. Let's add d3d12.dll. Finally, you can treat output as content and apply all these tremendous settings. That's it for now. You can ask me, so what? What next? And the next step is to create a new item. We can create new item called stdafx, stdafx.cpp, and its corresponding header. This is our precompiled header file. So to begin work with it, we should include corresponding header in C++ file and write some comments. This is precompiled headers. How we can use it? This time we will use some additional libraries. Let's use some low-level optimization stuff. We can manually exclude rarely used stuff from Windows headers. This one can be achieved by defining these lines of code. So this can drastically improve your build time. Finally, we can include frequently used headers. Finally, we can include windows.h and also include string. There are some caveats of using precompiled headers. You can manually include stdfx in every C++ file, so make sure that you have also exclude precompiled headers in third-party libraries if you have a lot of errors. Let's write some comments to easily understanding what's happening in this file. Feel free to include stuff that changed infrequently and used frequently in this header file. This is our precompiled header. Later, we will add DirectX12 support here. So let's write some boilerplate code. First of all, in each C++ file, we should include this precompiled header file. Let's implement the main function. This is our entry point. So, for simplicity, let's return 0 code for now. This means that our program is compiled successfully. Let's check this out. Press F5 and open the console. You have to check the error list. So, we have no imports of this library. This is okay for now. During this tutorial series, we will use object-oriented programming. Let's start with implementing our first C++ class. So to do that, we can add class called WindowApplication. This class will be responsible for drawing our window. So what it should include? First of all, Visual Studio automatically included our precompiled header file in C++ file. So what we have to do now? Let's implement some public stuff. First of all, we have to write run function and pass here some arguments. First argument will be h instance. The second one will be integer. The second one function will be function of getting our window. So let's call it getHWindow. And this one will return simply private variable. Let's return null for now. Let's write some modifiers, protected and private. In private section, let's define variable called m_hWindow. So this is our window. Let's return it in getter function. Also, we have to implement this function. To do that easily, you can click Show Potential Fixes and implement this function in C++ file. For debugging window, we have to write some additional stuff, helper functions. So first helper function will be parsing command line parameters. Let's add the mock function. We will implement it later, but for now I will comment it out. So this is useless for now. And we know that we have to somehow transform command line stuff to arguments. And we will do it later. For now, let's comment this out. But how can I show the window easily? To do that, we can initialize our window. Let's do this. First of all, add window class X. So this is our window class. This is empty class for now. Let's populate some inner variables. CB size. This one is size of window class X. Next one will be style of our window. For now, this is default style. For now, let's use default stuff. Next variable is window procedure. Let's use window procedure, but we have no window procedure yet. Next variable is h instance. Let's pass it out from our function argument. Next one is cursor. We can use default cursor and load cursor first h instance. The second one parameter is arrow. This is default mouse arrow. Next one is icon. Let's load icon from resource file, but for simplicity, we can load default icons. I will show you how to do that simply. We will make int resource. So here you can pass the ID identifier of icon. The second way to do that is load default icon from Windows. We can use IDI application. This is default application icon. To load icon from custom resource file, we should implement this resource file. For now, let's comment this out. Next variable is class name. I will use class name called DirectXEntry. Make sure that you write L symbol before this string. And that's it for now. So what we have to do next? We have to register this class. So pass the pointer to our window class. Because we have no procedure called window procedure, we must implement this in window application header. Let's write this procedure. This procedure is callback that returns L result, and arguments of this procedure are Windows defined arguments. This is default stuff from Windows.h and Win32 API. So let's create definition of this procedure. This procedure is responsible for some messages, for preceding messages from our window. What it means? It means that we have to implement message switch. First case is window create, window manager underscore create. This stuff is responsible for saving instance passed to create window. Let's define some structure, create structure, and reinterpret cast. So we have to catch some parameters and variables from our arguments. Next one is set a window long pointer. Here you have to pass h window, user data, and reinterpret cast, long pointer, and you have to pass here create struct and get create params. So that's it for now. Here you can return 0. The next case is kdown. This case is responsible for catching some input system events. So we have to write the case kup. Here we will overwrite some stuff and pass it to other functions or classes. Next one is paint. And next one is wm underscore size. This one is responsible for resizing the window. For now, this stuff is dummy. But next we have to disable some menu stuff to use with graphical user interface. We can use custom graphical user interface instead of WinAPI. So here we can disable alternative menus. And the most important case is a case responsible for quitting. So this case called Window Manager close. Let's follow through the next case. The next case will be destroying window. Let's call post quit message and pass that 0 value and return the 0. Last of all, we should return some procedure. Define it window procedure and just pass all arguments here. Window, message, and params. And that's it. This is our simple window procedure. Feel free to modify it. Let's do some important stuff. First of all, let's define our window as null pointer. Next, we can rewrite our run function. We can use window procedure here and there is no errors. Let's continue writing our run function. Let's use window rectangle to store some parameters. First two zeros are starting position of our window. Next one is our window height or window width. These parameters are not implemented yet. But how we can get a window width and height? So this is some complicated stuff. We can adjust window size to our screen size. And let's implement this later. For now, just create our window. For do that, we can call create window or create window W. So for simplicity, I will use create window W. Here you can pass class name from window class, window name from our name. This is hard-coded stuff, but later we will pass the name of the window here. Next one is type of the window, style of the window. I will use overlapped window and use default values to match the start window position. Next one is window width and next one is window height. For window parent, we have to pass null because we have no parent window. And for menu, we have to pass also null pointer because we aren't using menus. And for instance, we pass age instance. And for params, we will pass null pointer for now. Later in this video, we will improve this function. Let's show our window. To do that, you can pass age window and command to show. This one is passed from outer function. To update our window, we can implement some main loop. Simply, we can do infinite cycle. So how to do that? We can loop while our message is not equal queued message. And then we can process any messages in the queue here. How to do that? If we have some message, let's pick that message. You can call pick message and pass message. This is message pointer, window null, message filter 0, max and the minimum, and command remove. So after each loop cycle, we will remove one message. Then you can translate this message and dispatch this message. At this time, window procedure is called. So these messages are passed to our window procedure down below. Next, we can call on destroy in all nested windows. So you can return this part of the window manager queued message to Windows. How to do that? Let's return static cast to character, and return message w param. So that's it. That's it for run function. Let's check this out. We have two warnings, and there is issue here. We have empty main function. Let's execute our window application. How to do that? First of all, we have to return window application and call our run function. I will use double colon implementation of calling function. So here is how you can call any function from any class. And don't forget to include window application header file. But there's an issue. We have to pass some arguments in our run function. For now, we can hard code our h instance to pass a variable to our run function. Let's do that. H instance is new variable. This is empty for now. Pass it to run function, and the next parameter is 1. Means that we have to run this window. And that's it. You have successfully opened the window in C++. So if you like this video, please make sure that you subscribed to this channel. And let's run this again. This is our beautiful first empty window. Congratulations! Let's write some comments. This code for console application. By the way, access to the source code and exclusive content is already available to all Patreon subscribers. Make sure to check the link in the description down below. Good job so far! Now we are ready to add DirectX12 to our application. Let's add some new filters. I called my graphics. Make sure that you have filters in source files and header files also. So we have to add new class. I called my DirectXEntry. And what this class is responsible for? This class will be responsible for any DirectX stuff. What it means? It means that this is entry point for any our windows or viewports in our engine. Imagine that this class is our helper class for getting, for example, device or setting the window title. Let's include in our precompiled header file DirectX header. So we can write include d3d12.h and include DXGI1_6.h. Also, we have to include d3d compiler, and in our case, because we are developing game engine, we can use DirectX math library. So this can drastically help us develop our game engine. Let's include least but not last. We have to add d3dx12 header file, but we have no such file yet. Let's include WRL header file. But you can ask me, where we can get d3dx12 header file? First of all, you can go to Microsoft's GitHub page and download the header files, or, of course, you can get it with the project on the Patreon page. Check out the link in the description. So we have to organize our vendor stuff. Let's create new filter called vendor and add header file. I will call my d3dx12.h and just copy and paste some stuff in this file. But you have errors. You have to compile this stuff in one header. Don't worry, I got your back. I've done that for you. So you can just copy and paste this stuff and forget about it. Here is how the final file should look like. No errors. Huge, mind-blowing 4,000 lines of code Microsoft stuff. So this part is done. Get ready to implement DirectX_Entry class. So how we can do it? First of all, we can implement some helper functions and some variables. Each time you create a class, make sure that you implement initializer. In this case, initializer looks like that. We have to pass width, height, and window name in this class. Also, we can write destructor and write some virtual functions on initialize, on update, and on render, and on destroy. These functions are abstract. But what abstract means? Abstract means that you can implement it later in nested classes. Here, we can override the event handlers to handle specific messages. Remember, we have on key down or key up and so on. Arguments of these event handlers are key numbers. For this class, we need accessors. Let's write them out. Get width of the window. This one is constant. And simply return width of the window. Also, we have the same for height. Return window height. This is useful for some DirectX stuff. In case we have to resize the window and update window height and width. Also, we have to implement some helper functions for resources. We have to get asset full path to provide the full path of any asset, and we have to get hardware adapter in case when we have multiple or unsupported adapters. For example, GPU card that supports only DirectX 11 stuff, but we are using DirectX 12 stuff. So this function is useful to catch our boundary cases. So we have to pass the IDXGI factory one and adapter. Also, we have pass boolean value request high performance adapter. By default, we are not requesting high performance adapter. For example, if you have a laptop that supports two GPU cards, one is integrated and one is external. The next function is set custom window text and parameters for setting viewport dimensions. This is variables called width and height. M prefix means inner, so this means member of class. This is useful to store aspect ratio of our window and store adapter info. For example, warp device, and so on. We have to write some private stuff. Root assets path. This variable is responsible for storing assets path. And next one is window title. In case that you have multiple windows with multiple titles inside your application, for example, viewport, inspector, or file manager. Let's start with implementing our constructor. When we're calling this constructor, we can simply pass the data from our arguments to inner variables. Just pass the values after the semicolon. So we have to pass width value, height value, and also title. And also don't forget to pass warp device value. For default, we're using false value. And don't forget to set the inner variables. Here, we can set fspath array size equal to 512. The next, we can get assets and set the aspect ratio of our window. Here, how you can do that? You can simply divide the width value by the height value, but you can cast it to float. So here it is. We have get the assets path as null for now. Also, we have to implement the destructor of our class, and don't forget to implement other functions. So let's create definition for these functions and implement it later step by step. Let's start, for example, with getting the title of our window. To do that, we have to write some helper function called getTitle and return character value. So simply, we have to return the name or the title of our window. Next one is parse command line arguments. This is helper function, but we can implement it later, because for now we don't need it. It looks like this. For now, simply forget about it. But don't worry, we will implement it in the next video. So stay tuned. I always like to organize my code a little bit. Let's comment this function. This is helper function for parsing any supplied arguments. This will be useful for debugging purposes and so on. For suppressing some errors, we can use modifier called use declarative annotations. But we have one more issue. We have not set assets path value. If we simply change it to null, the error is not gone. So how we can deal with this error? We can simply put it in double quotas. And this is hotfix for now. Okay, good job so far. So how we can get assets full path? Simply we can return assets path, summing it with asset name. Let's implement getHardwareAdapter. This function will be much more complicated. So let's comment this out. Helper function for acquiring the first available adapter. This one will be responsible for selecting adapter that supports DirectX12. In case we have no supported adapters, we will return null. Firstly, we have to reset adapter value to null. There's how we can do it. Next thing we should consider of is using the pointers. We can use COMP1100 to track using the adapter and factories. Because this type is used by Microsoft WRL library, we can use this namespace in this class. So this command pointer is used to track pointer in memory, because we have data to transfer from GPU to CPU. And same technique is used for tracking the factory. So this is important. Let's query through all available graphic cards. Here how you can do it. You can call query interface from pFactory and pass the factory arguments. If this kind of operation succeeded, we can do some selection throughout our adapters. In such simple case, we can do for loop. Starting index of our loop will be adapter index, and this is 0 by default. Next one is boundary condition. To do that, we can use macro succeeded and pass factory enum adapter by GPU preference and pass adapter index, request high performance adapter, and in case we have no high performance adapter, we can switch to unspecified adapter. Simply, this line of code means that you have to select between high performance adapter and unspecified adapter. Also, we have to pass some arguments from adapter. And that's it. This is our loop. The last, we have to increment adapter index in case that we have multiple adapters in our system. So what's inside our for loop? Simply, for this case, we can choose the first found adapter. But feel free to implement some much more complicated stuff. For example, you have to filter adapters by some condition. And in this loop, you have to write some filtering stuff. But for now, let's simply choose the first adapter. To do that, we have to gather some information about our adapter. We have to store some values in descriptor. So we can get descriptor from our adapter and write it into descriptor variable. After that, we have to implement simple condition. If we have flags in descriptor and also we have adapter flag called, for example, software, because it means that you have no GPU adapter, only software adapter. Let's fix some errors for now. Here you can use descriptor1 and that's it. The errors are gone. Also feel free to format document. So inside this condition, we don't select the basic driver adapter. And that's it. That's it for our loop. Simply, we can continue executing a loop. And outside this condition, we can write some stuff. If we get there, that means we have some kind of device. And potentially, this device can support DirectX12. So we have to check this out. But how actually can we check Direct3D support? And in case we have no Direct3D12 support, we can create actual device. Let's try to create Direct3D12 device and check the corresponding result. So we can pass adapter in this function and we can pass features, D3D feature level. I will use 11 and also we have to pass unique ID of Direct3D12 device. The last argument is device itself or pointer to device itself. By now, we have to break this condition because we have created the device. The last thing that we have to check in this huge function is to check if we can get the adapter. If adapter is null, so we can again loop throughout all available adapters, pretty much the same that we have done above. So we have to check if we succeeded returning the enumeration of adapters by adapter index and pointer to adapter itself. The last thing, we have to increment adapter index by 1 for each iteration of this loop. Most importantly, inside this new loop, we have to do the same stuff that we implemented earlier. So simply copy these lines of code and paste it inside the new loop. Good job so far. Feel free to ask the questions in comments section down below. So what we have to do now? For now, we have returned some device. So where we can do it? We have adapter, we have factory, we have basic information about our device, and we have completed creating adapter. So we can return the adapter and set the pointer of adapter, simply calling detach. To set custom window text, we can append values to window text. We can get title value and concatenate it with some string and concatenate it with some text. So last thing, we have to set window text and pass here WindowApplication get window, hWindow, and the second parameter is our new window text. We can cast it to cstring. So, but there is new issue. We have no window application. So we have to include the window application header in our file. We can include it in C++ file or in header file. So I prefer to include it in header files simply because you have easily skimmed through all header files, and this technique is very helpful. By the way, you can include the header files in C++ files, as many developers do, so it's up to you. But I prefer to include in headers. Good job so far. We have finished DirectXEntry class. And now we can start to implement our graphics engine and improve our run function. Let's pass information about our nested classes. To do that, we can simply pass the pointer to our DirectXEntry in this run function. This is just one way to do that. Let's start with refactoring our code. So first function to refactor is run function in the window application. We can simply pass the DirectXEntry pointer as first argument in this function. So here it is. But for now, we have one more error. Identifier is undefined. To deal with it, we can include the header file or make the class friend class. I prefer to include DirectXEntry header file and declare the class. This step is unnecessary because we have also included header, but for this tutorial case, we will define the class DirectXEntry directly in the window application. Now we can pass some values from DirectXEntry class into window application. For now, we can get information from our DirectXEntry class. We can get width of the window, we can get height of the window, and calculate overall size of the window. So we can resize it later, depending on the screen size or screen position. We can call adjust window rect, pass the reference to window rectangle, and use the style of the window, we have used overlapped window, and we are not using menus. So this is adjusting window rectangle. To calculate the window size, we can use parameters of our rectangle. We can subtract right maximum value from left minimum value. And this is our width. And the same thing for height. Also, we have used DirectXEntry class. We have passed the pointer to our class in window. And also, don't forget to destroy DirectXEntry after the main loop is completed. Remember, we have event listeners and messages. So now it's time to implement some overrides. But for this, we somehow must get the DirectXEntry class. And for this case, I will use casting from our window. To do that, I have reinterpret cast and use DirectXEntry as class type. This is pointer to class. In braces, we have getWindow long pointer, and we can pass here window and user data. And this simple as it is. You can use this technique to get any nested window classes. So let's comment this out. Get nested classes. Let's use this pointer of DirectXEntry class to call onKeyDown event, passing value of pressed key as argument. So we can static cast our W param. And that's it. Just copy these lines of code and paste it in Window Manager key up, because we have changed only name of calling function. In this case, it will call onKeyUp. In Window Manager Paint, we have overrides onUpdates and call render. So this stuff will be implemented later. And that's it for now. Let's build this application. Press F5 and we have errors. Don't forget to modify our main function. Because we changed the WindowApplication run signature, we can also change it everywhere. But for now, we have no graphics engine class to use with DirectXEntry, so we can't simply pass here DirectXEntry. In this case, we have passed no pointer. And try to build our application again. We have one more error, because we have exception in case we have to implement graphics engine. The last part of this video will be aimed at implementing our own custom graphics engine class. So let's add the new class diagram. This class diagram can help us understand what's happening inside our project. And let's move it to the parents folder. Open this class diagram and add all headers. So we can just zoom it and unwrap all entries. You can't locate here C++ files, but we have only headers and we have all stuff included in these headers. I hope you enjoyed this video and it was easy to follow. By the way, all source code for this video will be available on the Patreon page. Feel free to contribute in this tutorial series in comment sections down below. Thanks for watching.